Now let's look at some octet rule exceptions. These are really not that uncommon. The most common type is to have more than 8 valence electrons because some of the d electrons become involved in bonding. There are also some that do less, that are happy with 6. So what we're talking about here is that I'm just going to draw a generic dot structure. So it would be if you have something like this that has an octet, but it has an extra lone pair, or it may have 2 extra lone pairs. Those are what most octet exceptions are like that. They have the extra lone pairs on the central atom. And you know that you've got these because once you put all the electrons on the outside, you have more than enough to go on the central atom. You kind of have extra, so you just go beyond 8. So extra ones go on the central atom. Less than 8 is a little trickier. You have to kind of memorize these because otherwise on the central atom you would be trying to make a double bond. So know that the main one is that we see this with boron. That's the really common one. Know this compound, that with it has 6 valence electrons on the boron. And we'll draw it here in a second. We'll see a lot of these. We're going to go through the geometries of these with more than 8 first. Now let's see what happens when you have 5 electron groups. When you have 5 electron groups, the electron geometry is what we call trigonal bi-pyramidal. And so what that geometry looks like is you have a triangle here, and it's a flat triangle kind of on the center, the equator, that's what we say, and it has one going up and one going down. Now, if there is an atom at all of these locations, every corner, no lone pairs, then the molecular geometry is also trigonal bi-pyramidal. Just like, every time when you don't have lone pairs, those two are the same, the electron geometry and the molecular geometry. Okay, if you have one lone pair, what you need to know is where that lone pair goes. And on this shape, the lone pair goes on the triangle. So we have 2 corners of the triangle that have atoms, one going straight up, one going straight down. If you don't know where to put the lone pair, you won't get the right geometry. On this one, the name of it is seesaw. And that's really hard to understand, based on how it's drawn there. So I did a little drawing here to kind of make sense out of it. I'm going to color code this. If I take this atom and this atom and I place them on the ground like this, and then this top one and this bottom one come across like this. And by the way, right here I'm not really drawing where the bonds are necessarily. It doesn't quite look like that. But this is the shape. So these two are on the ground. And so these are like seats of a teeter-totter or seesaw. And you've got kids on these. And of course, they can move up and down like a teeter-totter. I also show you this on the video with the animation. But anyway, that's where the name comes from. If we have 2 lone pairs, again, the lone pairs are on the triangle. We have one straight up, one straight down, one off to the side. And so it kind of makes a T shape. Okay, if we have another lone pair, – again, lone pair on the triangle. then we just have the straight up and the straight down. So you might guess the shape is just linear. Okay, next one, if we have 6 electron groups, so this would be like if you have 12 electron pairs on the central atom. The shape has the square in the center, where the other one had the triangle. It is a flat square, and then there's one up and one down. Okay. So the electron geometry is called octahedral. The reason that it's called octahedral is if you can look at these blue lines, it kind of shows you the geometric shape that it outlines, and that is an 8-sided geometric shape. So if there are atoms on all of those corners, then of course the molecular geometry is also octahedral. Okay. If there is a lone pair, here's our square. Unlike the triangle, on this one that's based on the square, the lone pairs are on the top and bottom. So without that lone pair, if we look at what's left, we have a square that's flat, and the central atom is flat on that square as well, but it has this one that's lifted up over. And so this is called square pyramidal. Last one, if we have 2 lone pairs, again, on this one, they're not going to be on the square, they're at the top and bottom. So we're just going to be left with our flat square. Our central atom is on that square as well. And a flat square we might call square planar.